Welcome back, guys. This is our second video regarding the series of the 8051 microcontroller programming using Keil. So today we are going to discuss the LEDs blinking code using the 8050 microcontroller and Keil µVision. Okay, so what are we going to do today? So suppose we have the 8 LEDs here. Okay, so suppose we have here 1, 2, 3, 4, 5, 6, 7, 8. 8 LEDs here, and here let me have here as well the same LEDs. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the LEDs. So suppose initially these are, the first one here is on, the third one is on, this one is on, and this one is on. Okay, these are on. So what does it mean? It means that this is 1, this is 0, this is on, this is off, this is on, this is off, similarly this is on, this is off. Okay, so after some time, what will happen? After some time, this second will turn on while the first one will turn off. Similarly, now the fourth one will turn on, the fifth one will turn off. Okay, this one will turn on, this one will turn off, and the last one will turn on. Okay, so what will be the code here? It will be now 0 1 0 1 0 1 0 1. Okay, so this is what, this is the condition here. So after this, when it will be on, so after some delay, it will be having some delay. Okay, and after that delay, this condition will occur. So initially it will have this one and then this one. So if I represent these numbers, this is 10101010 with hexadecimal number. So what it will be, let me have here. So this is what, this is A, and also if I see this one, this is A as well. So in hexadecimal, this is 0x AA. Okay, so this is 0x AA. Similarly, if I represent the similar one here as well, so this is here and this one here as well. So this is 5, this is 5, so it would be 0x 55H, or I can also write it like AAH in hexadecimal or 55H as well. Okay, so what will happen? This is, let me call it the port, some port, okay, with which these LEDs are connected. So let me call it port P1 of my microcontroller, and after some delay, this port will also be here as well. So this will be the port here. This delay will be created. After it, another delay will be created to hold this value as well, and after it, this will occur. Okay, so again, in order to represent it, this was the idea. What are we going to do today? We are going to give some, we will start the program. Okay, this is basically the program starting. After it, we will give some value to P1 port, which is what, which is AA. So let me have it AAH. Okay, after it, it will be having some delay. Okay, after delay, this P1 value will be changed to what? It will be now 55H. Okay, this is also H, so it will be 55H. Okay, so after it, it should hold it as well, and there will be some delay here as well. Okay, and at the end, what will happen, after it, it should replicate itself. Okay, just by coming here to this point. Okay, it will come back here, and at the end, we will have here this program ending. Okay, so in order to write all of this by using the microcontroller or assembly program, this start is always starting with or 00H. Okay, this P1. So in microcontroller we have seen that this will be done by using the move command, but by using the move command one of the operand must be A. So therefore first of all what I will do, I will move the value to A, which is this AA. So it will be hash 0 AAH. Okay, and then this value which is now in A will be moved to P1, and this is here. Okay, so this is the overall program because move cannot operate directly with P1. Okay, after it I have to call this delay, and in assembly program this delay will be done by using the A call delay. Okay, which is my subroutine. This one is the subroutine which I will discuss in our upcoming simulation. Okay, that how to create it. Okay, so after it what will happen, we have to do it again, the value of it should be changed. So again I will involve A. So in A I have to put hash 55H and then this value to P1 which is in A. Okay, so this is the overall function or the commands which will be doing this, and after it again I have to call the similar subroutine which is involved in creating this delay. Okay, after it we have to end it, but before ending it I have to do what? I have to here represent or do all the program for the subroutine which is for the delay. Okay, and then we will end it. Okay, this will be done like this one. Okay, so that is basically the structure of the program which we are going to follow. So let us move to Keil and do the necessary things. So this is basically the Keil environment. The same project is available in which I am going to type my assembly program. Okay, so I have already created, let me put it here. So this is the program. Initially you can see that this is awk00h. Okay, similarly I have given some label to the first command which is move to A00H, and then that should be move to P1, then A call delay. Okay, the similar thing which I have given to you earlier. Why I have given it a label I will explain it in a while. Similarly move to A hash 55H, move to P1 what is in A, and then A call delay, and then a jump again. Why jump again? Because the values on that P1 will be complemented every time whenever the microcontroller started. Okay, so as jump again means this is the label where it has to jump again, so it will jump again and it will replicate itself, and it will be what? It will be the loop instruction here. Okay, so this is for as jump, sjmp for as jump again is the label which is here. After it I have to create the delay as well, so therefore there is a subroutine which is for the delay. Okay, I have given it this name, and then I have to put it somewhere in the ROM. For that I have to give it some address. Let me put it at 60H, which will be starting point for the delay subroutine. Okay, giving it a name, and then this colon. Okay, this is the colon. So let me give some value to R1 0FFH to R1, and then here is again label. This is what DJ and Z. This is for decrement and jump if not 0 R1 to here. Okay, what it will be doing? It will be decrementing this R1 and will be jumping to the available label unless and until it becomes 0. Okay, so this is D, J and Z R1 here, so it will remain here because here is the label which is also the label for this line as well. It will be here unless and until this R1 will be 0, and this will create what? This will create the delay for this program. Okay, so after it is completed, R1 becomes 0, it will come out of this loop, and we will be here which is RET. RET means return. Return means return to the same program from where it is called. Okay, and after it we will end it. Okay, so this is what, this is the program which we have to do. Okay, so let me now follow the same things which we have done previously. So now first translate it. After translating it, I can see that there is no errors. Now let me build it. Okay, build is complete. So here we have here. So after it, let me move to a debug mode. So let me start it from here. Okay, so this is my program, and now in order to run it, what I can do here, now I have ports here. So let me move to peripherals. Here I have different peripherals, just like in ports I have port 0, port 1, port 2, port 3, timers as well, but now I have to go to port 1. Okay, this is the port 1, and the default value for port 1 is FF, which I have told you that it is because all the values written here are 1s on all the pins, because it will behave like an input port. Okay, so what do we have to do? Let me run it, and in running it, you can see that it is now replicating itself in the simulation mode. Okay, so after some delay, initially it is AA, then after some time it becomes 5 and so on, because of the sum instruction, because it will iterate again and again. Okay, you can see here as well. So in order to stop it, you can stop it from here, and you can see the values which are available here after stopping it. Okay, so from here you can reset it and start it again. So starting it again, you can see the similar operation here. Okay, so it will be stopped, and that is what we have done today. Okay, after it, you can go to your program as well. So if you have created an hex file, we will also talk about converting it to the full-fledged hardware design. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.